We have the pleasure, we have Larry Sullivan, who's a PE with Norwich Public Utilities, and also Andrea Braga, who's a PE with Jacobs. Larry has a Bachelor of Science in Civil Engineering from the University of Connecticut and is a registered professional engineer in Connecticut. He has 29 years experience in the water and wastewater industry with experience as a consultant as well as in utility management. And he's currently Water and Wastewater Operations Manager at Norwich Public Utilities. Andrea Braga is a PE with Jacobs. She's a Principal Water Resources Engineer with over 18 years experience managing and performing all phases of a wide range of civil and environmental engineering projects. Andrea has specific expertise in hydrologic and hydraulic modeling of stormwater systems, and in the design and analysis of green stormwater infrastructure technologies. Andrea has significant experience supporting municipalities, developers, and industry with the National Pollutant Discharge Elimination System, compliance and permit support. Andrea is also a registered professional engineer in Massachusetts, Connecticut, Maine, New Hampshire, New York, and Rhode Island. And with that, I will turn it over to Larry and Andrea.
There we go. Welcome back from everybody who stuck around for the late afternoon presentation. I know Paul earlier said he was Italian. He's hit his hands. He's going to walk around the stage. Me being Irish, I'm going to use this podium to my advantage because I need a place to set down my pint that I allegedly have. Thank you, Murphy. Norwich Public Utilities. We've had a lot of pipe breaks, force mains and gravity mains recently. Agenda, introduction to Norwich Public Utilities, if you don't know about it. Some of the challenges in our collection system, rehab projects, and lessons learned. Norwich Public Utilities, Southeastern Connecticut, established in 1904, just a little over a population of 40,000. We have all 4 utilities, water, gas, electric, and sewer, which makes it great for utility breaks. It's easy to coordinate, so that's a big advantage for us. Our system, there's a map on the side. It's a little small, but it's roughly 1850s, some of the earliest records we have, a lot of 1880s, early 1900s, clay, brick, concrete pipe, 120 miles of sewer, luckily 39 pump stations, about to get 40, which is wonderful to have. 13 regulars down to 11 CSO discharges. We have closed off 3 in the last 3 years after the flow monitoring showed they're really never going off. Our 1 wastewater treatment plant is in no, I don't have the clicker. In the middle, that just got, we're about to go under a significant renovation to that plant, which is long overdue. But right now, its average is about 5 MGD, and we can take 17 safely during wet weather flows. So some of the recent challenges we've had with a system at our age, and I think anywhere through New England, we've had CSO force main failures, gravity force main failures, like I said, a lot of I&I, some deferred maintenance from sins of the past, and a lot of the failures. If you can see the bottom right-hand picture, you can see that V-notch in the bottom. That's the cast iron pipe from 1973. When you pump that much grit and the stations turn on and off, it's basically a sawtooth on the bottom. It's a bottomless pipe, looks like a slit, and it's like sharp as a razor blade, and that kept us fairly busy. And again, nothing's outside of what anybody else has actually experienced in New England. So we've had 4 main rehab projects going on recently. We've had 3 major force mains. One has been repaired, 2 under the process of repairing. We have them bypassed, and an ongoing rehab project in one of the oldest sections of our town called Greenville. It leads to 5 CSOs. So with the actual details of all the projects, I'm going to defer to Andrea.
All right, thanks, Larry. We're going to talk about 4 of these projects. The first one being, okay, actually, let's go over an overview. Let's see if you can see my cursor. No, great. So we're going to start here with South Thames Street. We've got a pump station here, pumps flows up to Cove and combine over across the river into the wastewater treatment plant that's right over here on Hollyhock Island. Down here, we've got the River Ave pump station going up the force main to the Rose Alley pump station, and then across over again into this island where we have the wastewater treatment plant. So we're going to step through these. So the River Ave force main, about 2,800 linear feet of 14-inch cast iron force main Again, old aging infrastructure, 45 years old. Multiple previous repairs along this force main and failed leaks to the surface. As Larry had mentioned, invert erosion being the main cause of failures. That was what happened here at the River Ave force main. And the key challenges with this one, it was an emergency repair adjacent to active railroad tracks. So we've got some photos here, but our scope of work is really similar with all of these emergency force main projects. First and foremost, dealing with the emergency. So preliminary site visits, assessing the situation, where's the break happen, how can we get it under control. Installation of bypass system, and NPU's crew is great about going and responding to these and getting it under control, at least getting the immediate leaks addressed. So that we can have some time to move forward through design and construction. Evaluation of alternative rehab methods, and then preparation of plans, specs, and bid documents and construction phase services. So over here, we've got the CCTV in the upper picture here, and you can see the infiltration coming in from the invert where we've got holes because of the extreme invert erosion there. We've got the bypass pumping that NPU put in place so that we could evaluate the system. And then there's actually a photo there of the grouting of the force main in progress at the invert there. So after the evaluation of alternatives for dealing with this emergency, we selected pressure-rated cured-in-place pipe, CIPP. It maintains a similar hydraulic performance. Yes, the reduced inside diameter, but also we've got a lot smoother flow going through the pipe. It's quick and minimized impacts to the railroad property so that we could get in and out through that process relatively quickly. So you can see the before and after lining, and you can really see how smooth flow can go through there and the improved hydraulic capacity. But it was emergency restoration of the 14-inch force main by CIP. Avoided the need to excavate all the railroad. We know that there's a lot of delays that can happen getting the permits to do that work, so CIP was the best way to go. Grouting of the invert, like I showed in the previous picture, so that we could put the liner installed. And then collaboration between Jacobs, NPU, and Michaels, which is the general contractor selected for the job. Engineer's estimate was 2.2, contractor's bid was 1.3, and then it actually got done a lot cheaper than that, and that's really because NPU was able to do a lot of the earthwork, the bypass piping, all of that on their own with their crews, so that saved a lot of money on that end. So Greenville, Larry mentioned this project. This was actually proactive. This area really had a high infiltration. It was a high priority area, so what can we do to rehab the pipes in this system? Fully developed residential neighborhood, about 12,000 linear feet of gravity sewer, all those pipe types, but mostly clay, 100 manholes, and again, aging infrastructure in New England, 1800s, so a lot of old pipes. So it was really first to go in and take a look at these pipes and then determine what the best course of action is for rehabbing the pipes. Drivers for the rehab, like I mentioned, infiltration, invert loss, and then there was a partial collapse sections, as we'll see in the CCTV. Let's see if I can get my cursor back. Does anyone know what this is inside the pipe? Scream it out. It's a camera, CCTV camera. Fell in through a big hole in the pipe. So there's an issue there that needs to be addressed. So the first thing was to go CCTV and see what the problems were. That's certainly a problem. A lot of old infrastructure, like I said, right here, the picture right next to it. Can't see it that well on the screen, but it's a lamp hole. So fixing those where we could with manholes. Down in the bottom picture, I don't know where my cursor went. There we go. Any ideas what this is? Another pipe, another pipe going through the sanitary pipe. So something we want to fix there. And then, yeah, just the general condition of the other pipe, another pipe segment that was in disrepair there. So we did a records review, CCTV, flow monitoring, put it all in the design report, and then really phasing implementation of fixes, so plan specs, phase construction services, and then updating our record drawings. So phase 1 is completed. We did the CIP for high priority segments that could be lined, kind of focusing a big lining contract on that. A little over 6,000 linear feet between 8 and 15 inches in diameter, completed in 2021 by Aegion, and at a 57 per linear foot cost. I believe phase 2 is out to bid right now and includes 5 new manholes, 140 linear feet of pipe repair, a little over 3,600 linear feet of CIP, and then also some new pipe replacement as well. So really stepping through the Greenville sewer shed to proactively maintain these systems before they become the emergency situation. So Thames Street Force Main, the last 2 projects are on either side of the river here. South Thames Street pump station pumps up, and you can see all those pretty yellow stars where we had major issues, then failures. It goes up to Cove Street, and then under the railroad track, over the river, and to the treatment plant it goes. Emergency repair, like we said, this was a really challenging and continues to be a challenging location. Active railroad tracks under a state highway that was just recently paved, so we didn't want to do any work in the highway that was going to make us have to redo the entire roadway. Initially, the issue was leaking into the river, and then aged utility bridge that's taking it to the plant. So about 2,500 linear feet of 12-inch force main, 650 linear feet of 16-inch force main, and again, it was an emergency situation, multiple breaks along the Thames Street force main, and then also a break along the branch that goes to the river. So again, the big part was how do we get the system under control right from the beginning. NPU got their team out there, pieced what they could together with available materials, and got a temporary bypass in place to mitigate the initial discharge into the river. And then after we had that handled, getting in and getting larger material in so that we could have a longer term bypass as we designed the system. I mentioned the utility bridge, again, aging infrastructure and the issues associated with that. We did an inspection of the bridge since we were gonna have to be working with the pipes over it. Superstructure evaluation and substructure evaluation, you can see the cracked members in the utility bridge that are holding our force main in place, as well as severe deterioration of the piles underneath. So we worked into this design of repairs for the utility bridge as well. And then the railroad, we're going underneath the railroad in this case. 70 linear feet of 16-inch goes underneath. You can see this is our 16-inch force main on top, and then there's actually an abandoned, I think, 8-inch underneath. It's on a rail system, and then it's sort of being held up by cinder blocks or bricks cemented to this 48-inch CMP casing that goes underneath the railroad. So initially we had thought, let's get rid of that infrastructure, let's put in something new, and then fill the annular space in with concrete. It'll be nice and sound, and we'll all be able to go on our way. But really, this is a really old casing, and the question was, okay, if we touch it, we own it. And then there's also the fact that we needed to get it permitted through the railroad, and they had to be okay with everything that we were doing in their casing. And if we touched it, would they make us redo the whole thing? So there was a bit of a risk associated with that, and we decided to let's not touch it, and let's just line that segment underneath. We know that there was a break somewhere in there, and were able to CCTV it and check it out. But really, the solution ended up being let's line that segment and maintain the system in place as is. So these are the plans. The summary of recommendations, let's line what we can line, 2,500 feet in this case, of 12-inch underneath the state highway, because we didn't want to break up that highway and have to deal with redoing the road there. Line that segment under the railroad, like I discussed for those reasons and ease of permitting and whatnot. And then replacing segments that need to be replaced on either side, over the bridge and right before the bridge between the Cove Street pump station and the railroad. And then doing the bridge repairs to that utility bridge to make sure that there's safe conveyance of flow to the wastewater treatment plant. So the status of these projects are, the plans are done, approved by DEEP and the railroad. We're hoping to go to bid soon. We're just finishing up things with figure out our SRF funding for the project. And right now it's looking like a $3 to $4 million project, plus the bridge construction as well. And the last project I'll talk about is Rose Alley. Again, another failed force main, 3,600 linear feet, 20-inch, that goes to 24-inch. Pipe wall erosion was the failure mechanism in this case. Again, emergency repair. It was leaking to the river below the water line. So we were brought in to support getting a bypass installed as quickly as possible. Again, there was kind of a temporary bypass that was put in place to alleviate the initial discharge into the river, and then supporting the design of a more permanent temporary bypass over the DOT bridge and back into the parking lot here. So the failure is actually on this side of the river, so we stopped it before and we're going over the DOT bridge, so we had to do some permitting with DOT to be able to use their sidewalk to convey that bypass around and onto the island. We had a little bit of a delay because this is at the marina last summer, so we wanted to, and there was, I think, a ceremony or something happening there, so we had to put a little pin in it for a little while. We had the bypass in place, everything was being safely conveyed, and then we got back into it this fall to figure out where the leak is in the underwater section so that we could then propose a fix. So for this one, we CCTV'd, but it was underwater, so we needed a way to kind of dewater it in order to be able to see where the issue was. So we did camera inspection in order to do that, a phone pig to dewater up to the leak, and then a camera was kind of tethered behind that pig. So this is the pig actually blocking the hole, so now you can see it and get a good idea, and then when it moved a little bit forward, then you can see that we've got our location of our hole, because then the water started to pour in. So this was a really effective way of finding the location of the break there. We also did sonar of the flooded pipe to see if we could see the invert hole at that location too. Others say that they can read these. This looks like not a lot to me, but over here some people can see that there's a hole right there. It's going to be hard to see on the screen. Bill Cotter can come up and show you where the hole is if you want. But the CCTV actually proved to be a lot easier for us to really see where that hole was in order to design the fix for that. So our recommendations for this: install an internal repair sleeve right at that hole, and then go ahead and line it that segment under the river. Once we are able to block the hole and dewater the system, we can get the CIP lining in. Status of this project is the bypass is still in place. We've completed the condition assessment to be able to know where the hole is and develop plans to fix it. Our engineer's estimate was about $200K just for the lining portion, but when you bring in the general contractor aspect of the earthwork on either side to open up the pit, dewatering, removal of the bypass, the one bid that came in was significantly higher than anticipated at $1.1 million for site work and bypass decommissioning, lining, commissioning. It wasn't doable with what we have, so it was not awarded. NPU is going to take up the helms and do a lot of the site work, and then we're going to get that repair sleeve installed, and then hope to be rebidding just for the lining portion in late spring. So through these projects, we've learned a lot. The failure mechanisms with the CSO system, a lot of grit in the system, causes the erosion that we're seeing at the invert. There's been a lot of active and repaired leaks in the force mains that we know of, damage from utility construction like we saw. Excuse me. And then collaborative approach to rehab. NPU has their crew has a lot of capabilities in-house to go and respond to emergency situations and support repairs as well. So that really helps. And then, when you have an emergency, being able to really jump out there, assess the situation, and put what you can together to resolve the immediate issues with a flexible approach, pipe sizing, materials, whatever you can find, and then kind of get the immediate issue resolved and then work forward on a more permanent issue. And then it leads us to the conversation of what can we do about this instead of chasing our tails and always responding in that emergency action. What can we do to look at programs for managing the grit, be more proactive about maintenance of the system, and then optimization of pump systems. What can we do at the pump stations to help us mitigate the issues in the system as well? So with that, I'll open it up to questions. Or not? All right, thank you.